Okay, so originally I had this as my first example, which you'll see in a bit, but you realize it's really long and it's really big, so I'm just going to do this one first and show you this. But know that the top part is coming, so prepare yourselves. Okay, percent composition of oxygen in dinitrogen tetroxide. So we are using our prefixes to name here. I know that this is a molecular compound. So dinitrogen means that I have 2 nitrogens. Tetroxide means I have 4 oxygens. Let me fold this so I don't have to hold it up. So when we talk about percent composition, we are always talking about the mass of something. And we're talking about the mass of nitrogens and the mass of oxygens. In this case, they want to know the mass percent composition of oxygen. So I know that I have to be working with grams, because that is what percent composition means. I have to find the percent of each one according to the mass. So what I have to do is first find the mass of nitrogen in this compound. I know that nitrogen is 14.007. Lost the focus. There it goes. Better? Nope, not at all. There it goes. I know that nitrogen is 14.007, but there are 2 atoms of nitrogen because I have this 2. So I have to multiply this by 2. And then I have oxygen. So I know that oxygen has a mass of 15.999. 15.999. And I have 4 oxygen atoms because I have this little 4. So I have to multiply that number by 4. So now I am ready to use my calculator to figure out these numbers. So 14.007 times 2 is equal to 28.014. 15.999 times 4 is equal to 63.996. So I have a total mass of 28.014 grams for nitrogen. Let me put grams here. Boop, boop. And I have a total mass of 63.996 grams of oxygen. Okay, so when we talk about mass percent, that formula is going to be mass percent is equal to whatever I'm trying to find, whatever mass I'm trying to find. In this case, I'm trying to find the mass of oxygen, divided by the total mass times 100. Oop, there it goes, times 100. So if I am trying to find oxygen, because they tell me find oxygen, then I'm going to use the mass of oxygen up top. So it's equal to the mass of oxygen at the top divided by my total mass. So the total mass is when I add this mass plus this mass. So the total molar mass of my compound. So that is 28.014 plus 63.996. My total mass is 92.01. 92.01, and I have to multiply that by 100. So now I can use my calculator again to solve this math. So I have 63.996 divided by 92.01 times 100, and that is equal to 69.6 approximately. 69.6% oxygen. So that is my answer. So within dinitrogen tetroxide N2O4, I found each mass made up by each element of my compound. Remember subscripts, because you have to multiply those with to get the appropriate mass. If they ask for oxygen percent composition, I need to find the oxygen mass divided by the total mass of my whole compound, which is what I did here. I added these two numbers. To get 92.01. So whatever I'm trying to find the composition of, divided by the total mass, times 100, and that is equal to my percent composition of oxygen.